when we look here, it says recall, direct variation. What is that graph? What did we say it was? We looked at it. It looks like a what? It's right there on your paper, guys. All you do is read. Javi, you going to take that off your head for me? Thank you. It's a line, right? It's linear. Then we said, hey, the inverse is not linear. So where this guy is a line, y equals kx. Remember we said that was just like y equals mx? No plus b, though. No plus b. So where the k works like the slope, right? So now we are going to look at this guy. So you possibly want to grab your calculators if you don't have it quickly and quietly. And Jimmy, just grab one of the bottom ones down there. Not the one that has the broken screen, though. I keep forgetting to look at numbers. Okay, so we're going to look at this guy together. Sam, you're 42. You're 42. Is that there? Okay. So, first of all, an inverse variation problem or equation is also called a rational function. Okay? What is a rational number again? Your most favorite kinds. Fractions, right? Thanks. There you go. So your most favorite kind. So now we have a function that is a fraction as well. Okay? So you have the k, we said right here, right? Right here. This is your line. This is now your rational function. So go ahead and write up here y equals, and we're going to look at 1 over x as our parent function. Remember when we talk about the parent graph, it's typically, oh yeah, there's Austin. It's typically the one that we haven't multiplied anything to, added or subtracted. Justin, are you unplugged? Austin, you going to unplug yourself too? Thank you, darling. We haven't added, subtracted, or multiplied anything to it, okay? So here we have a chart with not a lot, actually with no numbers written on it. So let's start and let's work on this together just so ours kind of look the same. So if I put in a 1, if I decide x is 1 and plug it in, what does y equal? 1, right? Okay. So what about 2? Oh, no. What happens when I plug 2 in? Right, it's 0.5 or 1/2. Either way is just fine, okay? So plug 2 in and you get 1/2. What about 3? Good, so I'm just going to put 1/3 because we're just going to kind of estimate it right now when we graph it. Since our grid lines aren't specific and they're only on the integers, we're just going to estimate that. So guys, I'm plugging my 1 into this. Okay, we good? I'm plugging my 2 in there. When I plug 2 in, I get 1/2, and when I plug 3 in, I get 1/3. Okay, so now what we're going to do, and guys, we're kind of doing this by hand, so hang with me for a second, okay? So now we're going to look at 1, 1. We're going to look at 2, and we're just going to hit 1/2 right there. And then 3 and 1/3 we're going to hit right there. Okay? Well, now do you see that this looks like it is approaching down there? Because what would happen if I put a 4 in?
You get 0.25.
Right, and then 1/5, and so it would get closer and closer down there. I'm not going to plug all those in because I have other numbers I need to look at. Okay? So now, you ready to put your thinking caps on? I'm going to tell you that x is 1/2. So you have 1 divided by 1/2. How are you going to put that in your calculator, Miss Evans? Will you throw that in the calculator up there for us?
It's easy to do.
It's 1 over 1/2 or 0.25. Yes, 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 please. So guys, you will put it in parentheses. It's on the struggle bus too. Yay. Okay, so look up there. You have to put it in parentheses. Perfect. 1 divided by 1/2. Right? Everybody agrees? Look up at the TV. That's what it has to look like. So you get 2. So what do you think is going to happen when I put a 1/3 in there?
3.
Yeah. 1 divided by 1/3 is 3. Okay?
What happened when I didn't use parentheses?
Yeah, look at what happens then. Yikes.
Same as 2, right?
So look here, because if I go over to 1/2, then I'm going up 2. So it's right there. Okay? If you did not do that, your 1/2 is going to drop it here. Because you said it was 1/2, right? And it's going to look ugly if you put it in your calculator incorrectly. So I took my 1/2, which x is 1/2, and it's up at 2. Okay, so now I'm going to estimate over at 1/3 right here, and then that's going to put me up at 3. So what do you think 1/4 is going to do? It's going to put it up at 4, and it's getting closer and closer and closer there, isn't it? Look how cute this graph is. It's not ugly. It's very cute. And look at what it's going to do. It's going to approach it. Do not touch this guy. That's trying to be an arrow. Sorry, guys. That's trying to be an arrow. And then it approaches it like this. So let me ask you one thing. I said it approaches it, and I said don't touch it. And mine blocked because I left my pen there too long. Okay? Touch this. Because what is this value? What is the...
0.
So it's the y-axis. It has the x value of 0. Okay? What happens when you plug 0 in here? Well, yeah, put it in your calculator and see. 1 divided by 0, right?
Yeah.
And what do you get?
Error.
Error, right. Because as soon as you do that, as soon as you plug in 1 divided by 0, that thing's blowing up. It is not defined, okay? So therefore, it can't touch that that y-axis. It can't touch it. It just approaches it. Okay. Now, did you also notice, so ladies and gentlemen, did you notice that my graph, even as bad as it is trying its best to approach both of those axes, okay? Does it look like this? No. Because look, is this right here, does this look like it's trying to do this?
No.
It looks like you think, oh yeah, that thing looks like a parabola. Let me put a parabola right there. It is not a stinking parabola. It is approaching the axes. It never touches it though. For today, it's going to approach them always and not touch. Monday, it's going to be a little different. Okay? So right now, just hang with me. This is, terrible. Okay? Do not. It is not a parabola. It is a curve that approaches. Okay? Y'all good? Can you tell how people draw me parabolas before?
What is it?
I've had people that have drawn me the red before. Okay, so that's a no. Okay, so now, oh, I have lots of more blanks. So what happens, we said we can't put in 0 because I got an error, right? So if I put 0 here, it's not defined because you get an error, or you could put error or whatever. I'm not gonna write that in my chart, but it is not, it is, yeah, nothing. It's not defined there.
What about negatives of those?
Thank you. Yes. So what happens when I put -1 in? What do I get? I get -1. What happens when I put -2 in?
-0.5.
-1/2, right, or -0.5.
You're just gonna jump to conclusions.
-3, you're following patterns. I don't think it's jumping to conclusions. I think you're following a pattern there. -3 is -1/3. Okay, so when I go -1, -1, there you go. -2, 1/2 is that. -3, 1/3, and then it's going to do exactly the same thing, and it is approaching that. Okay? Now, what happens if I plug in -1/2? Oh. -2, right? Yep. So it's going to be -2, and then I'm going to add my -1/3 here, and what's I going to put it to? -3. So here, when I go to -1/2, it's going to go down to -2. -1/3, it's going to kick it down there, and it's going to approach that as well. Okay, so how cute is that?
Not as cute as
So now, let me ask you the other thing. So let's look at, so this is, I'm going to put my blue one here, and it's trying to do the same thing, okay? And do you see that it kind of comes in and it curves, and it's trying to do that? Okay, so now, this is what it is not doing. If it is right here, it is not doing this and a hard angle like that. That's not a right angle. Do you see my cute blue curve there is not a right angle, okay? So don't come and draw it like this. This is no bueno. No bueno. Okay? It has to lay out and approach both of the axes each time you draw them. Okay? So now, let's look at these parts. Okay, so it says the graph has 2 parts. Each part we call a branch. Okay. It never crosses the x-axis or the y-axis. So I told you for today, it's not going to cross that. Did you try to get our sleepers awake? So with that, today it's not going to cross, okay? To Monday, it could be shifted that it may cross, but this is just for today because we're not shifting it or moving it anywhere. Okay, so it never crosses the x or the y-axis. When you have this happen, we call the lines that it never crosses asymptotes. Asymptotes, yes. It has a P in it. It's one of those funny English things. And it's written right here. Asymptotes are lines that a curve approaches as it heads to infinity. So technically, these lines are imaginary. We don't draw them on your graph, okay? So when we do the asymptotes, we would show them by dashed lines. Whoops, sorry. Okay, so when we draw an asymptote, we are going to do a dotted line. So make a note of that down here. They are dashed. And when I say, I don't know that it's So when I say it's imaginary, if you would draw the line solid, it makes it look like that's part of your graph, which is not. It's just the line that it's approaching. Okay, so now we get to look at some good stuff. It said, did you notice also, this graph never crosses the origin? Well, if it can't cross either one of those lines, and that line crosses at the origin, it's not going to cross that. These guys always look like this. They look like this. They're in the, what quadrant is this? Who remembers what this is?
The first.
Yay, this is the first one.
And I'm guessing now the.
And you go, yes, counterclockwise. So these guys are in quadrants 1 and 3. Okay, it says the function is not defined at 0. We already said that because when you plug in 0, it gives you an undefined. It's not, it gives you an error, so it's not defined there. So the domain.
All real numbers except 0.
Nice. You're going to say all real numbers. Give me that double R, but you can say X cannot be 0. All reals, or you can write it out if you want to.
I'm guessing it's the same for Y except.
You can write out all real numbers, but X can't be 0, or you can use that notation right there. And similarly, yes,
You all right?
likely, the same here. It's not defined for Y to be 0 as well.
Y does not equal 0.
So the range, absolutely, are your all reals,
It's a lot better than last time when you graph stuff.
but Y does not equal 0. Guys, kicker, X and Y's. When you're talking about domain, you better tell me X's. When you're talking about range, you better tell me Y's. Okay. Now, wow, look at this guy. Let's back up, and I'm going to slide it up here again. If we're moving, if it's talking about increasing or decreasing, remember we're moving left to right. So if we are moving left to right here we go. This function, as soon as we see it, do you see it's already moving down? Because as soon as you hit it, the function does like this. Except it freaks out for a second. It jumps way up here, but then when you're moving on it, do you still see it's moving down? So it's moving down. Woo, freak out. Jump up. Moving down. Okay? Moving down. Freak out. Jump up. Moving down. Okay? So it is decreasing except for what? Right now, this one is just for X equals 0 because that's where it's not defined. So the freak out is where it's not defined. And then Anila, did you say it restarts? Yes. So that freak out part is, it's like your calculator freaking out and telling you error. And then it goes, bah, and it jumps up and then it comes down again.
Wait.
Alex.
If there's no increasing, why is it on here? The graph's on the back. Last time.
Well, we'll get there.
I'm guessing that behavior is the same.
Okay, just stop, please. Okay, so now, let's look here. We said it's not 0, X can't be 0. We are going to put a little bit of a reason because it is not defined here. Okay, and then we say also that the graph has symmetry with respect to the y equals x line and the y equals negative x line. Okay, so what you're going to do for a moment is you are going to get your Desmos computers. So we have let's see, 2 and 2, 2 and 2. Okay, so
We doing the pairing up?
yeah, just pair them. I think we can pair everybody because I think we should be even now, right?
Yeah, it's just one.
Just- Uh-huh. She wasn't. I did. Um, so they're there. Quickly, leave your phone.
And then do you want Javi and Justin maybe?
Yeah, that's fine.
Together? Okay.
So if you will turn around and work with Will behind you, please. And if you'll go back and work with Alex for me today, thank you, darling. And then,
I don't think this one's
but
charged.
I think we're good. Everybody's tuned. It's not
I know, it's
charged.
good. It just took a bit.
What? The computer?
Yeah, like if I put 0,
That's the freak out, right? So y'all are good. You might want to grab that since he's in the restroom. Yeah. Stop grounding.
I've just been angry today.
Let it go for the class. Just let it go. What? Okay. I'm glad you appreciated that. Okay, so now what we're gonna do is we are going to plug in, so everybody should log into Desmos. If you see on the back, the next page, it says you log into Desmos there, okay? So you're gonna log into Desmos for a second, and you're gonna do follow those directions for me. No, Anila wasn't here.
No, Aaliyah.
Oh, Aaliyah, I'm
No,
sorry.
sorry, Aaliyah.
Aaliyah.
I can look, I mean, it's fine, I'll remember. Oh, maybe I'll remember something different. They weren't marked out, so.
I didn't do it?
Mm-mm. Yeah.
It was Aaliyah.
Okay.
Yep,
Sam
that's
was
it.
tardy. Samerson was tardy.
And Caesar.
And Caesar, that's
Gosh, why
right.
didn't I do that? Okay, so everybody should go to Desmos. Yes, and start graphing. And then it's asking you to investigate. So work through this, write some stuff down, okay? And let's see what you come up with. You over here?
It gets straighter every time.
Desmos. Oh, okay. Oh.
What does it even mean? It's just- Yeah, so the acid, whatever changes.
Not for Desmos. That's it right there. What?
Asthmatosis.
Yep, there you go. Yes. So guys, you should have 3 different graphs, and it shows you in 3 different colors. Okay, so let's look at these.
Asthmatosis means like it's going to, like it changes to infinity. So it can't change from a line from infinity. It's going to infinity.
Are you okay? Okay, do you want to go out?
Well, that's infinity over there. Like this area. Past 6 and stuff.
Okay, Alex, you need to decide whether you're gonna stay in class right now and do the lesson or not, okay? It's up to you. Anthony, I need you up working with Sam, so he's not on the struggle bus by himself.
Did you hear him go?
We're all on struggle buses, it's Friday, just like struggling. We're aware?
I'll try to hold on to this one.
Oh, I don't know that, I mean, I know what it is, but I don't.
I'm on the struggle bus today. Today I have to run a mile. I don't feel
Okay. So guys, you have some questions you should be answering. Okay, so why are we not talking? Come on. You don't understand what? Oh, so guys, it does say choose a point. So if you go and let me toggle over here, you can find the points on Desmos, which is fine, okay? Because I grabbed them. Yeah, she did. She might be right there though. How many are you needing? Yep, I have 4 that I hadn't used. Yep. So guys, if you look at Desmos here, we're trying to anyway. Oh man, is it not gonna do? I think I'm good. Okay, give me a second. So guys, if you look here, and I said y equals 1 over x, okay? Now, it says to find a couple points. Or how many did it say? Find 3 points on, well, actually, it said to find it on the 4 over x, so don't use my points. But look, if you do this, you can find some points, but what's the problem with the points? They're decimals. You can technically use them if you like. You can use them if you like because you're still going to get the same thing. Do you see that I can jump and find any of these points? Or you can use your graphing calculator. Put it in your graphing calculator. Desmos shows it cuter because this is not going to be as cute. But let's look right here.
Then you have this error rate, doesn't it? Error rate, if you want to type something like aspirin or whatever. Yeah.
Okay, so if I look right here in this graph, see that, ladies and gentlemen, this graph is very much like that, okay? However, it's not as cute because you can't see the colors, and then when I added the other one, you have to kind of look. But how can I find the points on this graph easy? The table. Yeah, so go and look at the table, and then here you can find the nice points. Okay? So you can use your Desmos to see which one is which and what happens with it.
So then we multiply it.
So is that what it said to do?
Yeah, now multiply it when I first.
Oh, yeah, so then multiply, so your 2 points, had you even taken the decimals, it would have been okay, as you're going to get the same idea. But yeah, so go ahead and write your 3 points down, and then multiply them. Yeah.
How did you do that?
Oh, dude. I mean, it's for.
Uh-huh. Yeah. Did you see what you're doing here? You're good. Did you see what you're gonna do with the calculator? Plug it in your calculator. Instead of here. Do you see that they're graphed? How they're graphed here? Do you see it's
What's that? What do you multiply by? What do you mean?
And then you multiply them together and tell me what you have. Yes. When it's asking what? When you multiply them together? Yeah, why is it occurring? Because of the equation? Kind of, yeah. Okay, we're getting there. So guys, look here. Let's make sure we have the same thing written for this. And some of you got a little. Y'all ready? Okay. So what did you notice? If you notice when you put the graph, did you notice they started getting farther away from the origin? That's what we were getting at. Some of you noticed a little bit, a little more of that, but you should have noticed that that gets farther away from the origin. If you wrote down other information, that is fine. We are probably going to get to that in the notes. Okay, and then it says, okay, choose 3 points here for number 2. Somebody give me a point that they chose. What was it? 2, 2. What's another point? 4, 1. And then what did you say, Sam? Did you say it?
Anthony.
Oh, Anthony, what did you say? Good, -2, -2. So these were just 3 points. You could have picked any 3. It didn't matter. And then what does it say? Multiply them together. What happens? Wow.
Oh my goodness.
Oh my gosh. Right? Why is this the case?
Because the constant variation.
Ding, 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 ding. Jordan, say it again. Listen. Because the constant of variation is 4. What do we get when we multiply x times y? What do we get? K, right? X times y equals K. X times y equals K.
That's what I'm going to do.
X times y equals K. Right? So that's what you're getting. It's an inverse variation. That's what it graphs. Wherever our graphs are, they're not anywhere else. So y'all are good. Yeah, that's what it, thank you. That's what it graphs. Okay. Oh, nuts. Okay, so did the same thing happen right here? I hope so. If not, you didn't multiply. Well, somebody give me a point that you picked.
9-1.
9-1.
6 and 1.5.
6 and 1.5. Thank you for picking an ugly point.
8.
8 what?
8 1.2.
25, right? 8 and 1.25. When you multiplied them together, what did you get? 9. Why is this occurring? You know it now, right?
It's the way life goes.
Yes. Say it again.
It was right there the whole time. The constant of variation, it says y equals 9 over x.
And it's K, right? Yay! Because it is the constant of variation. Okay, that's really ugly, but that's what it is. Okay. So now let's look at what we are going to look at here. So basically, ladies and gentlemen, I wrote here, so it's noted, it's it's bolded, whatever it is. It says to calculate the constant of variation from a graph of the inverse variation only from the inverse, because if we don't have an inverse, we don't have a k value. All you have to do is pick a point and multiply the coordinates together. And that's what we did with our charts yesterday, our tables as well, okay? So corner points, wow, what is a corner point? First of all, does my graph technically have a corner? Does it have a, yes, no. That's why, oh, nuts, we didn't even put them in. That's why they should be in, what are these called?
Asterisk.
Oh, quotation marks?
Yes, quotes. Real ones, right?
See what she was holding up.
Because it does not have a corner. But we call it a corner point, and it's going to be your best friend because then we only need 1 point to graph it, and then boom, bam, we're good. Okay, so their corner points are called corner points, and it is where the graph intersects this line y equals x, right? Where y equals x, which, hello? Hi. Hi. So that means if y equals x, that means if x is 2, what is y? If x is 2, what is y? 2. If x is 10, what is y? 10, exactly, okay? They have to be the same. So this right here, ladies and gentlemen, is supposed to be y equals x. It's a goof, so please change that on your notes. So what points would satisfy, so we know we need 2 points that multiply to give me 2, and they also have to be the same. So what is that? Oh, I just said it. They multiply to give you what? 4. So it is 2. So 2, 2 then is what we would consider our corner points. So we are going to put corner in quotations because it's not a true corner. Okay, so the points on this graph that are, and these guys are the closest to the origin. If you look back on your Desmos and you go and you find it, it's the closest point to the origin, okay, and it's going to be the integers, or the whole numbers, well, I guess integers, because some of the times they're going to be negative. Okay, so in this case, we are going to look, if we have this to be the corner point, how did we find that? You said it was 2. It is your constant of variation. And how did we get, well, so we got 2 here and we got 3 here. What's a mathematical way to get that?
Multiply. No, subtract. Okay, wait, restate your question.
Okay, so I have 9.
All right.
So what do you think my corner point is going to be? Because it has to equal the y equals x. 3, 3, right?
Okay. 3 for x.
Right, but from 9, how did I get 3?
The square root.
There you go. There you go. Okay, so we have an ordered pair that is going to be the square root of k and the square root of k. We also have, if Miss Evans, if you will look and point to the one in the quadrant 3, the blue one in the quadrant 3, okay, that point right there, Austin, that point right there, is it going to be the square root of k still? So in this case, the corner point is going to be 2, 2. What if k was 4? What is my other corner point going to be? Look at where it is down there. What's that point going to be?
1.
We're pretending it's this graph, so it's got to be,
It's gonna be 2, 2.
this is 2, 2, but what about in that quadrant? What? Thank you. It is going to be -2, -2, because it's in quadrant 3. So you can look at the negative square root of k and negative square root of k. And that's going to give you that other corner point. Yeah. Okay. So now, We ready to flip over? No. You don't, but this is going to be easy now because the domain, I told you what it was already, right? Good. It is all real numbers except 0. Remember, it can't, when we looked at, if you come back to your Desmos, does everybody still have those 3 graphed on your Desmos? Yeah, so if you have those, it's a struggle. Thank heavens it's Friday. Okay, so if you have these on Desmos, then you still see they're very similar. Okay, there they are. They're very similar there, okay? They're pulling away from the origin like we said. However, do any of them ever cross there? No, so that's exactly the same. So here you're going to tell me it is all reals, but what? X cannot be 0. Guys, this has to be put there. You have to put that there. All real numbers. You have to tell me X can't be 0, right?
Except X equals 0, or all real numbers
But X cannot be.
not equal 0.
Okay, so look, the range, all reals, but Y cannot be.
Can they say all reals, comma, X does not equal 0?
All reals, comma, X does not, yes,
Okay.
yep. All reals, once again, but X does not equal 0. Range, all reals, but Y does not equal 0. Okay, so did the X value, I can't even read. Does change in the K value of the inverse variation change the domain or the range? No, it doesn't, right? Because it is defined by the X. The K value is a constant, okay? And we also can say no, because did our asymptotes change at all? No. So no, and I would just say because the asymptotes are the same. And the denominator is X. It is the same. And basically the domain and the range, we limited the domain and the range because of X being in the denominator. Okay. So now we're going to look at what happens when we can change the K value. And let's go ahead and put to a negative. To a negative. So now go on Desmos. Go back on Desmos, and then you can, if you click on the color over there, it will if you click to unhighlight this, it'll take your graph off so you don't have to look at thousands of graphs. BQ, wake up. Thank you. So look, it does that, so I don't have to look at that. But what's going to happen if I put a negative in? What happened? Did y'all see yet?
Yeah.
What?
It flips. It flips.
What do you mean it flips?
Like, it mirrors.
It mirrors, it flips. I wish it wasn't. Let me see if I can change this color. I think if I exit out and then change it, it'll give me. I just didn't like it because it was
You can even see like that.
It mirrors over the x-axis.
Yeah, good. Okay, I like it better in purple because you can tell it a little better. So exactly. And Jack, why are you telling me it mirrors over the x-axis? Because it does. You're right, it does. What did the negative do in every other
Oh, yeah,
function?
flipped it.
It flips it, right, over the x-axis, and that's exactly what this is doing as well. Because then here you set based on the knowledge of transformations, you hopefully could get there. If not, you sure had the aha moment. Okay? Yes, so it reflects it over the x-axis. Now you have to be specific. Okay? And it does change the quadrants. Changing the quadrants. And that's what we're going to look at down here. Okay? So it says where k is positive, we already talked about that. What quadrant did it lie in? 1 and 3. Okay? So when k is positive, there you go. When your k is negative, the branches are in 2 and 4. Okay? So we are almost there. We are almost there. We're going to write a couple steps out. Miss Evans, could you grab the computers? Guys, log off your computers real quick because we can use our calculators if we need to, just so we can get those back up and we don't run out of time. Okay. Oh man, I don't think it's recording anymore. Shoot. Oh yeah, it is. Okay, so with that, let's write a couple steps down. Step 1, you are going to take the square root of k to find the corner points. And what are we going to do with corner? Put them in quotation. So guys, Miss Evans will grab them. Y'all fine. We'll come bring them to you. Okay. Then what are we going to do? We're going to draw vertical and horizontal asymptotes, and I'm going to show you how to do that. Okay. So you're going to draw vertical asymptotes. At x equals 0, you're going to draw a horizontal asymptote at y equals 0. So that's step 2. So you're going to draw vertical asymptotes, or tote at x equals 0, a horizontal asymptote at y equals 0. Then you are going to plot your corner points. Thank you for grabbing those. So you're going to plot your corner points. You've got 2 points to plot. Let me put those in quotes. Then draw branches. What do the branches approach? The x and y, right? So in the x and y axis in this case, but they also were in general it's your asymptotes. Okay? So you're going to draw the branches approaching asymptotes. Nice. Okay, so let's see what we can do with this guy. We have 2 to look at. Okay? So let's keep thinking about your rules, okay? About what to do. Now, here it says that you're looking for your horizontal asymptote and your vertical asymptote. They're always the same at this point. Monday, I'm going to change my rules a little bit. You'll see how it changes. But what is my horizontal asymptote? It's y equals 0, the horizontal line. Vertical asymptote is x equals 0. Okay, and now it says so what is my k value?
16.
K value is 16, so the square root of k then
4.
is 4. Okay, so the square root, so I just wrote that up there because that would be the square root of 16 is 4.
Then it would be 4, 4.
Perfect. It's going to be 4, 4, and what? Negative, because we've got them in both quadrants, right? We have them in quadrant 1 and in quadrant 3. So I just said since k is 16, I took the square root of k, and I really should have put 16 there. I just didn't, so I didn't mark it out. So the square root of 16 is 4. Okay, we good with that? Okay, so where did we say these asymptotes are? The axes right now, right? So draw it. How are we going to draw it? Solid line? Dotted line, dashed line, right? Because it's not part of the graph, so we can't make it solid. So if I dashed my asymptotes, just like that, there they are, right? Okay. So now plot your points. So at 4, 4, there it is. So there's my point. At -4, -4, do not, ladies and gentlemen, whoops, I missed it. It should be right here. Okay. Do not draw me a bird either. Yeah. So when you draw this, it approaches, right? So you're going to start here. Now remember, it kind of curves. It's a smooth curve, okay? It's a smooth curve. Do not make this look like a bird. I'll show you what a bird looks like in a second, but not on my nice notes, okay? So look, I'm going to smooth. Smooth, right? Smooth. It's approaching. Smooth that way, right? Don't look at my other, I put down there. Okay, so what's a bird look like?
It's really curvy.
Oh, you know I cannot draw anything with a feather on it, right? So here, if this is it, how many times have people done this? When you draw a sunshine, when you learn to draw that sunshine, and you said, oh yeah, that's a bird, that's a bird. Don't make it look like a bird, okay? It doesn't look like.
I don't want to see birds and buttons, birds and buttons.
Okay, so I'm going to take your mind, make it look bird. Okay, so it's a smooth curve, right? Okay, so now, okay, here we go. This is easy. This is easier because domain and range are nice. They're all real, but what?
But X is not equal to 0.
Nice. But x does not equal 0. That's almost free points. Range. All reals, but y does not equal 0. Is this guy increasing at all? No. So you're going to tell me none. Do not tell me not applicable because it does apply. It just doesn't exist here.
So it'll always be 1 for increase.
No. We got to look at the next one. As soon as we do the reflection, it's going to be a little different. Okay. Decreasing, oh, wow, where's it decreasing? Everywhere, right? This one right here, darling.
No, decrease.
Nope, it's not increasing. You have to move left to right. Read, like you're reading it. Read it, and it's always decreasing, right? Correct. I was not trying to say right and left. Okay, so it is decreasing where? Everywhere, but x cannot, at x equals 0. So it is decreasing at all reals, but
X and Y.
do we say where x equals 0 or x does not equal 0?
But x does not equal 0.
Yes, it's still the same.
Except where x is.
Right. Okay, so there, you can write that just like your domain there. Okay. Now remember, in behavior, we're looking both ways, as x goes to positive infinity and as x goes to negative infinity. So you're in behavior as x approaches positive infinity. What does y do? So as x, okay, so here we go. We're kicking out here, right? We're kicking way out here. As it goes out and out and out and out and out, what's it going to approach? Okay, so where is negative infinity?
Oh, on the bottom.
So if x is getting bigger and bigger and bigger, and it's shooting down, like if you have a parabola, right? As you go this way, it's going to negative infinity, correct? Okay. So here, as we are approaching positive infinity, what is this approaching?
Nothing.
The asymptote, right? Is going smoothly to the asymptote, right? What's it approaching? What is the equation of that asymptote? Yeah, so y approaches 0, right?
Why is it approaching 0 though?
Okay, but do you see that this is going all the way? It will never touch that asymptote.
So how is it approaching 0 if it's never was?
Right, it's a, yeah, y is approaching, because it's approaching, it never gets there. It's always getting a little closer and a little closer and a little closer. And a little closer. You can take 1 over a million and it's still not 0. It's 0.0000000, and there's a 1 somewhere out there, okay? So now, as x approaches negative infinity, okay, as x approaches negative infinity, it's kicking this way. It's kicking, here we go, as x approaches.
Y approaches negative. Y approaches 0.
So there's my not bird, right? So
Y
good.
approaches 0 again, or
So if I'm coming to negative infinity, I'm going out here. Where's y approaching?
0.
The asymptote again, right? Which is, good, y is 0. Okay, so now, let's look through this last one so we can look at the difference, because it is a negative, it is reflected, so we've got to look at that real quick. While I'm doing this, Miss Evans, will you grab the homework for them? There's only 3 problems, y'all got it. Okay, so what does this negative do right here?
Okay.
Flip it.
It does. So it's going to put it in quadrant what? 2 and 4. So I went ahead and I noted that just there, just so I don't put it in the incorrect quadrant. So my horizontal asymptote, y equals 0. Same thing, vertical asymptote, x equals 0.
Ooh, I know this one.
Corner points.
Negative.
Oh, we got to be real careful now. Yes.
Negative 3, then 3, negative 3, then negative 3.
Good. So guys, this is a little different because since it's reflected, it's going to be, instead of up here at 3, 3, it's going to be at 3, negative 3, and then negative 3, 3. That puts it in the other quadrant, so be careful with that. So it's going to be 3, negative 3, and negative 3, 3. And then you are going to draw your, no birds. You are going to draw your asymptotes, and then you are going to make it a smooth graph. Smooth. You drew a bird? You didn't even think about a bird until I said it, right? Okay. Wow. Guys, this right here, domain, exactly the same. It's going to be different, isn't it? So x does not equal 0. All reals, but y does not equal 0. Now, this guy is always increasing, because if you move left to right, it is getting bigger and bigger and bigger. It's going to freak out a little bit, but then it's still going to be increasing, okay? Guys, I have 5 minutes. Have a seat, please, darling. Okay. So with that, increasing are all reals, but x cannot equal 0. What about decreasing? None. Okay. What about this?
X goes to positive infinity, about 5 goes to 0.
Yep. Y approaches 0 again, because it's still, as it's going positive infinity, that thing's still kicking right there to that asymptote. And as x approaches negative infinity, that's what it's doing there. It's going, y is approaching 0. You guys rocked it today. That was a long lesson. Well done.